Okay, today is one of those lessons that you can do the long way. In other words, you can do it any way you see fit, or that you can do the best. But the truth is that mathematics is all about finding these shortcuts and patterns, discovering patterns, and recognizing that there's a quicker way to do things, to get the same answer. Many of you do that even in your own work. As you're doing things, you find ways to cut corners and get the same result. Obviously, we don't want to get an incorrect answer, but we want to be able to do this quickly, efficiently, and accurately. And this is just a prime example. Today's lesson is all about the binomial theorem. When you learned about it in Algebra 2, more than likely they grouped it together when they talked about probability, and they did it in the form of combinations and such. I don't really find that it makes a lot of sense when we do it that way. That is a way to approach this, and that is one of the primary reasons why we do it. Because basically it's determining the number of combinations that you can get when you're multiplying things out. And let me explain as we proceed. Maybe you'll get a better picture of that. But when we look at this a plus b cubed, if I asked you to multiply this out, you would do a plus b times a plus b times a plus b, and of course you would group two of them together. And I'm going to group these two just for looks. It doesn't really matter because they're both the same. You'd have a squared plus 2ab plus b squared. And you would take that quantity and multiply it by a plus b. And when you multiply this out, I'm going to do it mentally, we'd have a times a squared, that's your a cubed. Then we would do a times 2ab, and that would give me 2a squared b. And you move in, right? We move both of these in a spot, and you would get another a squared b. So I'd get 3a squared b. All right, the next term occurs when you multiply a to the n, and you get ab squared, and you're going to move in, and you get 2ab squared. We can't move in again because of those parentheses, so again, I get 3ab squared. Lastly, we're going to take this b now to the last term, and I get b cubed, and we can't move in anymore. So that would be what a plus b cubed is. Now, in number 2 on your homework assignment, you should look at those answers and see about what is it that the mathematicians found quite unique. If you look at the questions in number 2b, it was asking you x plus 1 cubed, and that was the response you got. In 2c, it said x plus y cubed, and that was the response you got. Do you notice a pattern here, or do you notice something significant, that each one of them all have a coefficient of 1, 3, 3, 1? Well, Pascal noticed this, and this wasn't just some fluke. He thought, let's look at the others. Let's look at some other things. If I do x plus y to the 0, I get 1, because anything to the 0 power is 1. Okay. X plus y to the first power, you just get x plus y. Nothing significant there. If we get x plus y squared, every single time, if you haven't already noticed that, you always get the x squared term. You get 2xy and then y squared. When the cube, just like we did in the last slide, you notice that each of them had the coefficient of 1, 3, 3, 1. What about the fourth? 1, 4, 6, 4, 1. And then to the fifth, 1, 5, 10, 10, 5, 1. What do you think would be for x to the 6th? If we were to do x plus y, oops, can't write here, x plus y to the 6th. What do you think the first term would be? Great. And the second term, what do you think that's going to be? Now, here's the trick. What you want to see is that the exponent, what happened to the exponent each time? It started at 0, then it went to 1, then the x was x and then a y, then we had x squared, we had x cubed, we had x to the 4th. Interesting, huh? So what do you think the x is going to be now? X to the 5th, and y is 1. Each of those, the y was 1. All right? Now the next term and the subsequent terms is where the pattern starts to wander a little bit. You have to be a little intuitive and think, how could I get to 10? Is there something ahead of it that might give me that clue? Is there something around it that might give me that clue? Something from the problem that might give me that clue? So I want you to look at this and see, you have 1, just looking at the coefficients, 1, 1. Then you'd have 1, 2, 1. Then you'd have 1, 3, 3, 1. Then 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. 1, 6. What could this next term be? And that's what Pascal discovered. And it is what we now call Pascal's triangle. If you look at it, it looks a little confusing, but you'll notice that Pascal's triangle, it's just because they put these weird boxes around it, but you'll notice the triangle is formed with 1s all the way down the sides. So every row will always begin and end with a 1. Know that. Every one of them. All right? So every row will begin with that. Now, how could I have gotten this 2? Can you see that this 2, how did we get that? Or maybe the 3, or the 4, 6, 4. Does anybody see how we could come up with this line, 1, 6? How could I have come up with that 15? Because there is a pattern. And I'm hoping at this point you can see that what you do is you basically add the 2 numbers that are over it. So if I was to look at the row 1, 6, 15, 20, 15, 6, 1, if you'll notice 1, right, goes there. We always start with a 1. 1 and 6 make 7. 6 and 15 make 21. 15 and 20 make 35. 20 and 15 make 35. 15 and 6 make 21. 6 and 1 make 7. And then again, you always begin and end with a 1. This goes through the entire table. Now the significance of that is absolutely huge, because now when we ask you a question, a plus b cubed, I actually don't have to multiply it all out. Or a plus b to the 6th, or x plus 2 to the 6th, or any other number to any power. We can actually do it in a shortcut way. And I want to show you that. And I want to get this box off here, so give me just a second. There we go. Okay. Just bothered me. All right, a plus b cubed, we already did that one, so I'm not going to go into that too much, but I'm going to show you how the shortcut is used here. So what we do is, this is the row we use. I can tell because it has the 3 as the second term. The 3 will line up with the power. So when I get to the 6th, I'm going to use the row with 1, 6. Okay, if that was to the 8th, I would use the one that says 1, 8. All right, so a plus b cubed. It always is going to start with 1. So it's going to be 1, and then I take the first letter, or first element, whatever is right here, and I'm going to take that to the highest power. So it's 1a cubed plus. The next coefficient is going to be 3. The next one will be 3, and the last one will be 1. So what goes in these spots is key. So next to this 3, here's what happens. This first term was a cubed. It's now going to drop down to a squared. And we introduce the second piece. The next term is going to drop down to a to the first. But what happens is, as that first term is going down in powers, the second one, b in this case, goes up. So it becomes b squared plus 1. A drops down a power. So now instead of being a to the first, it's going to be a to the 0, which is 1. Great. And b is going to go up to 3. So let me show you to the 6th power. Different color here. All right. Looking at this row with the 6, I already know my coefficients are 1, 6, 15, 20, 15, I'm going to write it below here, 6, and 1. So all of these are my coefficients. I just have to figure out what is the letters, or what are the variable parts of each of these. So again, let me remind you. You take the first term, and it goes to the highest power, so that's a to the 6th. The next term, we already know its coefficient. What's going to happen is that a, or that first term, is going to go down in power, so it's a to the 5th, and we introduce the second, so it's a to the 5th, b. The 15, that's the number, that's the coefficient part. The a is going to go down to 4, and the b is going to go up to 2. 20, it's a cubed, b cubed. The next term is going to go down to a squared. Notice my a's are continuing to go down, and the b's are continuing to go up. And then it goes a to the first, and b to the fifth, and lastly would be b to the sixth. Now another important little helpful hint here is, we understand that we're raising this to the sixth power. If you look at the exponents of these, they will always add up to that power. So in this case, they should always add up to 6. So you'll notice the first term is to the sixth power, so 6 and 0, if you want to put that with b. And the next one is 5 and 1, which makes 6, and 4 and 2 is the next, and 3 and 3. It's evaluating every combination of letters. We could have 6 A's and no B's. We could have 5 A's and 1 B, and how many ways can we get that? How many ways can we get 4 A's and 2 B's? How many ways can we get 3 A's and 3 B's, and so forth? All right, now let's look at how to do this with a number, because it would be great if it always looked like that, but let me show you an example of with a number. When you see a number here like this, x plus 2 to the 6th, the approach is still the same. Now I'm going to do it relatively long here, but hopefully you'll understand as we go through. The coefficients are still the one for the line with 6. So it's still going to be 1, 6, 15, 20, 15, 6, and 1. The numbers that are next to it, or rather the variable part that's next to it, that's the part that'll make it change and not just look exactly like the one above. So just the same approach. We're going to take that first term, x, and it's going to the highest power. So my first term is x to the 6th plus. The second term, x is going to go down a power. And instead of b here, we're going to put the number 2. 2 to the 1st. The next term is going to be x to the 4th times 2 squared. See, we're treating it just like the b. The 20 is going to be x cubed, and then it's going to be 2 cubed. Then we have x squared, and we have 2 to the 4th. Then I have x to the 1st, and I have 2 to the 5th. And lastly, the x has gone down, and now I have 2 to the 6th. You can see now how we can get different coefficients in the front, because that number 2 is going to alter this, because I have still x to the 6th, that's all fine and good, but I'm not going to have 6x to the 5th 2. I'm going to multiply these two guys together and make 12x to the 5th. The next one is going to be 15 and 4. And 15 and 4 makes 60, x to the 4th. The next one is 8 and 20, so that's 160 x cubed. The next one is 16 times 15, and I don't know what that is, so I'm going to do that real quick. So I get 240 x squared. And then I have 2 to the 5th, which is 32 times 6, another one I don't know off the top of my head. So that's 192 x, and then 2 to the 6th, which is 64. And so this is what x plus 2 to the 6th power is. Now you might think, wow, that took a long time. But if you took x plus 2 times 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 x plus 2, and even if you group them together in 2s, and even if you multiply them mentally, I'm telling you, I would beat you every time. The binomial theorem makes this much simpler, and these patterns will help us tremendously as we go through.